Good morning, students. You are welcome to the online teaching of Regina Patches Model Secondary School on Nature. My name is Ifeka Alachike, your further maths teacher. The topic we have for today is dynamics, Newton's laws of motion, specific objectives. By the end of this class, you will be able to 1. State Newton's laws of motion and apply the formula involved. 2. Solve calculations based on the Newton's laws of motion. Go over to Newton's first law of motion. It states that a body continues in its state of rest or uniform motion in a straight line unless it is acted upon by an external force. What is it telling us? It's telling us that a body at rest, maybe if you are sleeping, that you will continue sleeping unless somebody wakes you up. That person that wakes you up is an external force. And even that person didn't wake you up, you would have continued sleeping. We go over to Newton's second law of motion. It says that if a force acts on a body and produces a certain acceleration, then the force is proportional to the product of the mass of the body and the acceleration takes place in the direction of force. That's the resultant force acting on the body. You can see it in the word, in the formula. In the formula, you have the force directly proportional to what? Ma. This is the force M. M is what? Mass. A is the acceleration. Remember, this proportional sign, you have to clear it. If you clear the proportional sign, you introduce a constant. Remember, this becomes F equals to Kma, whereby K equals to what? Constant. It's very important. But K equals to 1. Then you now have it that F equals to 1 times Ma. Then we have F equals to Ma. But remember that acceleration is the rate of change of velocity with time. So we have A equals to V minus U over T. If you insert it here, it will now be F equals to M bracket V minus U over T. This formula and this formula are the same. This is the first one for force, then this is the second one for force, also known as resultant force. Remember, where F equals to force in Newton, M equals to mass in kilogram, A equals to acceleration in meter per second squared, U equals to initial velocity in meter per second, V equals to final velocity in meter per second. We go over to Newton's third law of motion. It states that action and reaction are equal and opposite, or it states that to every action, there is an equal and opposite reaction. This is also applicable to nature. If you prepare well in the exam, you reap what you sow by getting what? Distinction. That is what third law is also telling us. So we'll go back to calculations. Calculation number 1, it says a horizontal force of 0.6 Newton acts on a body of mass 0.3 kilogram. There is a resistance of 0.15 Newton opposing the first force. What is the acceleration? We go back to solution. From the question, we have it that the mass is 0.3 kilogram. Look at it here. Then from the diagram, if I draw it, this is the mass of the body, 0.3 kilogram. We have the force, 0.6 Newton, acting this side. Then on the opposite side, which is the resistance, we have force of 0.15 Newton. Then we have to find the force, which is the resultant force. To find the resultant force, you now say 0.6 Newton minus 0.15 Newton. And it will give us 0.45 Newton. So using the formula F equals to Ma, we have 0.45 equals to M, that is 0.3 times A. So we have 0.45 equals to 0.3A. You make A the subject of the formula, divide both sides by 0.3. If you divide both sides, you now have A equals to 1.5 meter per second squared. We now go over to number 2. Number 2 says two forces, F1 and F2, act on a body of mass 2.5 kilogram. F1 has magnitude 5 Newton in direction not 30 degrees east, and F2 has magnitude 8 Newton in direction east, E. Find the acceleration of the body. The first thing you have to do is to draw the diagram. Without the diagram, you cannot draw. So if you draw the diagram, remember you start with cross. That's the 4 cardinal points indicating the north, south, west, east. Remember here is 90 degrees. Then if you look at here, F1 has magnitude 5 Newton in direction not 30 degrees east. Look at it, not 30 degrees east. So this is north, this is east. So 30 degrees, you start from the north, then you put your 30 degrees. Then you draw the line, then you place your 4 cardinal points here. Remember that F1 is 5 Newton, so this is F1, You write your 5 Newton, you draw your F2. It says F2 has magnitude 8 Newton in direction east. So here is the east. So you draw it, this is 8 Newton, F2. Then you place your 4 cardinal points. Remember, if here is 90, here will be 90. If here is 30, here will be 30. So you have your 90, 30. Then you draw your what? Your F1. If here is 5 Newton, here is 5 Newton. If here is 8 Newton, here is 8 Newton. At the end of the day, it forms a parallelogram. Then you draw your resultant. Look at it, draw your resultant. This is the resultant first, and that's what we are looking for. So using cosine rule. Remember, from the diagram I drew, you now carve out a triangle. From that diagram, I have here as resultant R, I have here 8 Newton, I have here 5 Newton. Then I have the angle between 8 Newton and 5 Newton as 120 degrees. So this has formed a triangle. So we're going to use cosine rule, and according to cosine rule, it says a square equals to b square plus c square minus 2bc plus a. So you make R our a, you make 5 Newton your b, you make 8 Newton your c. So according to this cosine rule, a square, that is r, a is r, so r square equals to b square, b is 5, so 5 square plus c, c is 8, so 8 square, minus 2bc, so it will now be minus 2 times 5 times 8, times cos of angle a. Remember, this is angle a, that's the side facing angle, side a, look at the angle faces side a, so that is angle a, look at angle a here. So we now have it as 120 degrees. So it will now be times cos 120 degrees. So we now have r square equals to 5 square is 25 plus a square 64. Then minus 2 times 5 times 8 will give us 80. Then times cos. Here this is cos. So it will now be 120 minus 180 degrees. So we have r square equals to 89. That is 25 plus 64 will give us 89. Then minus, remember this minus is a demarcation between here and here. So you bracket. You now do this one collectively and get a simple answer before joining it with what? Minus. You have 80 times cos. Look at it, 120 minus 180 to give us minus 60. So here we have r square equals to 89 minus bracket 80 times minus. Remember, cos minus 60 is minus cos 60. So we have r square equals to 89 minus bracket 80 times minus cos 60 is 0.5. So minus cos 60 will give us minus 0.5. We now have r square equals to 89 minus 40. Then we have r square equals to, remember that minus times minus is plus. So we now have r square equals to 89 plus 40. We have r square equals to 129. Remember, square this side, coming over to this side becomes square root. So we have r equals to square root of 129. And that will give us 11.36. Remember that this r is what? Resultant force. Therefore, you now say F equals to 11.36 Newton. Then you now apply the formula. F equals to MA. We now have 11.36 equals to M is 2.5, so times A. So we have 11.36 equals to 2.5A. You make A the subject of the formula, divide both sides by 2.5. Now have A equals to 4.54 meter per second there, square. Take your assignment. Assignment number 1, it says a horizontal force of 1.2 Newton acts on a body of mass 0.6 kilogram. If a resistance of 0.30 Newton opposes the first force, find the acceleration. Number 2, two forces F1 and F2 act on a body of mass 5.0 kilogram. F1 has magnitude 10 Newton in direction not 60 degrees east, and F2 has magnitude 16 Newton in direction east. What is the acceleration of the body? So this is where I'll stop. We'll continue next time. Remember to read your books, do my assignment, stay safe and remain blessed. Thank you.